Example 17. The average cost function and demand function in ringgit of a company that manufactures computer chip are C bar X is equal to 2000 over X plus 4, and the Px is equal to 40 minus 0.002x respectively, where X is the number of computer chips manufactured. Find A, the cost function. Okay, since the question already given the average cost function, we can obtain the cost function by multiplying the average cost function with x. So this is a formula for the cost function. So we just substitute the average cost function and times with the x. After simplify, you will get the answer 2000 plus 4x. 17b. Find the maximum revenue and the number of computer chips shown to achieve this. Okay, so now the question asks us to find the maximum revenue and the number of computer chips sold to achieve the maximum revenue. Okay, so as we know, to find the revenue function, we can use the formula Rx is equal to Px times x. Okay, look at the solution. So Px are given in the question, so we just substitute the Px and then multiply with the x. After we expand, you will get 40x minus 0.002x squared. Okay, so that's our revenue function. In order to get the maximum revenue, we have to differentiate the revenue function. So after differentiate the revenue function, you will get 40 minus 0.004x. Okay, in order to get the number of computer chip shown, so we have to equal the marginal revenue function to 0. So you get 40 minus 0.004x equal to 0. After we simplify, we will get negative 0.004x is equal to negative 40. So our x is equal to 10,000. After we get the x equal to 10,000, so we have to differentiate for the second time to get the answer negative 0.004. Okay, so which is less than 0, so it's a maximum. Means that x equal to 10,000 is a maximum. Okay, after that you just substitute the 10,000 into your revenue function to get the maximum revenue, which is 200,000. Okay, so at last we can draw a conclusion that the maximum revenue is RM 200,000 and the numbers of computer chips are 10,000 units. 17C. Find the maximum profit. Okay, to find the maximum profit, first of all, we have to find the profit function. As we know, the profit function pi x is equal to Rx minus Cx. This is a formula. So let's look at the solution. So we just substitute the Rx, which we get at the part B, and our Cx at part A. Okay, just now we already Get it? So we just substitute Rx is equal to 40x minus 0.002x squared minus with your Cx is equal to 2000 plus 4x. So you will get 36x minus 0.002x squared minus 2000. Okay, so there's a profit function. To get the maximum profit, we have to differentiate the profit function. So marginal profit function is equal to 36 minus 0.004x. And we let the marginal profit function equal to 0. So you'll get 36 minus 0.004x is equal to 0. So after simplify, you will get negative 0.004x is equal to negative 36. And then our x is equal to 9,000. After we get the x equal to 9,000, we have to use the second derivative test to test whether it's a maximum or minimum. So we have to find the second derivative for the profit function. The answer is negative 0.004, which is less than 0, means it's a maximum. So means that x equal to 9,000 is a maximum. After we reconfirm it is a maximum, so we have to substitute the 9,000 into our profit function. You will get 36 times 9,000 minus 0.002 times 9,000 square minus 2,000. So after simplify, we will get 160,000. So we can draw a conclusion that the maximum profit is Rm 160,000. 17D. Find the maximum profit if each chip sold is tax Rm 5 ringgit. This question involves the tax. Okay, so before we solve this question, let's look at some information. Tax is charged by modifying the original cost function. Tax is charged for each unit of product. So for this question, the new cost function, including tax, is Cx is equal to 2,000 plus 4x plus with 5 ringgit multiplied with the x, unit of product produced. Okay, so the cost function will change if the product involve the tax. So let's look at the solution. Okay, now we have to find the profit, maximum profit. So we have to get the profit function. Since the cost function already changed, so the profit function may change also. Okay, we substitute our revenue function, which is same as a part B, 40x minus 0.002x squared. Okay, minus with our new cost function, which is 2,000 plus 4x plus 5x. Okay, so after we simplify, we will get 31x minus 0.002x squared minus 2,000. So this is our new profit function after tax. The next step, we have to differentiate the profit function to get the marginal profit function. Our marginal profit function is equal to 31 minus 0.004x. The same step we have to go through, so we have to let our marginal profit function equal to 0. Okay, you will get 31 minus 0.004x equal to 0. So after simplify, you will get the x equal to 7,750. So to test the x, whether it's a maximum or minimum, we have to use a second derivative test. So after we do the second derivative for the profit function, we get negative 0.004, which is less than 0, means that is a maximum. So x equal to 7,750 is a maximum. The last step, we have to substitute the x into our profit function to get the maximum profit function. So you just substitute into the profit function, you get 31 multiplied by 7750 minus 0.002 multiplied by 7750 square minus 2000. Okay, so final answer we will get 180,125. So we can draw a conclusion. The maximum profit is RM 118,125.